Hello class, today we're going to continue our discussion of right triangles in trigonometry by solving applied problems involving that. So here we have an example of a problem, and we're actually going to use what we've been working with in class to solve this. The angle of depression from the tee box to the green is 10 degrees on par 3 in a 185-yard hole. How much higher is the tee box than the green? Well, first of all, if you ever played golf, this is where you start off with. This is our tee, and we're trying to get the golf ball to go into this hole over here. The angle of depression from the tee box to the green is 10 degrees. So this angle right here is 10 degrees. And the actual par, the hole, is actually 185 yards away from the tee box. So this is 185. Oops, can't write. Okay. And they want to know how much higher is the tee box from the green. So really what they want to know is here, what is this height? Okay, and as you can see, even though I didn't do a good job of drawing the actual right triangle, this is actually a right triangle because we want to know how high the tee box is from the tee. Okay, and we're trying to find this side of a right triangle. And they want us to round our answer to the nearest yard. So there is actually a multiple step process that you can do to help you solve. The first problem is to determine what unknown side or angle you were asked to solve. So in this case, we're asked to solve for this side, and compared to the angle they gave us, this side is actually the opposite side of the 10-degree angle. So that's what we're asked to solve, the opposite side. Oops. Okay. Or actually opposite leg. It's up to you how you determine it. Opposite leg. Let me just correct that. Opposite leg of the 10-degree side. The second step is to identify what side lengths, opposite leg, adjacent leg, or hypotenuse, and or angle measurements of the right triangle given. So we are already given that we're dealing with 10 degrees. So we have a 10-degree angle. I'm not doing it in the order they say, but still. And we actually are given which side length. Are we given the hypotenuse or are we given the adjacent leg? Well, the hypotenuse is unknown, but we are given the adjacent leg to this angle. So here is the adjacent leg. And they tell us it's 185 yards. So we're given the adjacent leg to the 10-degree length of the 10-degree angle. And that adjacent leg is 185 yards. Okay? So then, now that we've done that, the next step is to determine which trig ratio I'll use based on my answers from 1 and 2. So I'm given the 10-degree angle, the adjacent leg of the 10-degree angle, and I'm trying to find the opposite leg. So which trig ratio involves the opposite and the adjacent legs of an angle? Well, if you said tangent, you're absolutely correct. So actually, the ratio that we're going to use is the tangent ratio. Now at this point, you can use the circles that I showed you on page 93, or else you can use set up the tangent ratio and solve this problem. Now step 4 is determine if I'll be using the tangent ratio or I'll be using the inverse tangent equation. In this case, we're going to be using the tangent equation, so we don't have to worry, because the reason why we're trying to use the tangent equation and not the inverse tangent is we're not trying to find an angle measurement, we're trying to find a side measurement, and that's why we need the ratio and not the inverse tangent. And then the next step is to set up the equation based off what we know of what we selected in number 4. Okay, so since we're doing the tangent equation, I'm just going to set that up right quick. Tangent of an angle is equal to the opposite leg divided by the adjacent leg. Okay, So let's set that up, and we're going to set this up filling in the information that we know, okay? So we said, okay, well, we know that the angle measures 10 degrees. Okay, so I substitute that in for angle A. And I know that the opposite leg is what we're trying to find, so I'm going to call that X. We don't know what X is. So we don't know what the opposite leg is. And I'm going to divide it by the adjacent leg, which we know is 185. Okay? Now if you're using the circles, you can use the circles to tell you what operation to do to get X by itself. But we're actually going to use algebra or even proportions to do that. And the way we use proportions is we set up this proportion. Tangent of 10 degrees over 1 is equal to X over 85, and we can cross multiply and then divide to get our answer. So in order to solve the equation, all we have to do is solve this problem. So I'm going to use my calculator, and as we can see, another problem. We're going to figure out what tangent of 10 degrees is. So make sure it's in degrees, and again, we're in the scientific component, not the standard component. Make sure it's degrees. I'm going to type in 10 and then hit tangent, and that tells me what the ratio is for tangent of 10 degrees. And then I'm going to multiply it, because when we can cross multiply and then divide to solve proportion, we're going to multiply it by 185 yards. And then to figure out what X is, divide by 1. And we get that the answer is 32.62 yards. And so that's our answer, 32.62 yards. And we did all of that using this problem. Now, for those of you who want to use the circles, let me show you how to use the circle. So here we have the circle, and since we're going to use tangent, I picked this tangent circle. And since I'm trying to find for the opposite leg, in order to use the circle, I cover up the opposite leg in the problem, and it says in order to find the opposite leg, I'm going to take the tangent of the angle and multiply it times the adjacent leg. So we're going to go over here, press clear, and take the tangent of the angle and multiply it times the adjacent leg, which was 185. And we get the exact same answer as well. So we have more than one way to figure out this answer, using the circles or using the great standard equation. Okay? All right, that's it.